Hello guys, welcome back to Maison African Motives, still on mathematics and that is working on the integration part. So in this platform, what we are simply going to do is to introduce the integration. We work with question papers. As you can see here, I'm having a lot of questions like these typical ones to integrate the following with respect to X. These are the typical questions that you end up knowing how to simplify as we are going to be discussing. So like I said, we're just going to have an introduction of this integration exactly, then answer these typical questions so that we can tell what to do and how to integrate such typical questions when given. If we are to note here, we've got the first part that we just need to understand from our integrals. So let me just do it this way. If we are talking about the integration, we are just referring to the reverse of the derivatives part. Here we talked about the derivatives previously, where we were differentiating ax to the exponent of n, and this was the formula that we were using. So it's simply the reverse of this part. Like for an example, if we are to differentiate with respect to x, let's say we've got 3x to the exponent of 4. This is a derivative with respect to x, where we are going to drop the exponent. 4 multiplies with 3. So this is going to be 12x to the exponent of, you subtract a 1 on the exponent, that's n minus 1. So this is going to be 4 minus 1, which is a 3. So that was on the derivative. Now we are saying if we are to integrate, the reverse now of this derivative is the integration. So if we are to integrate this part, which is 12x cubed. So this is the sign for integral, all right? The integral of 12x cubed with respect to x. So this dx is simply meaning with respect to x, to the letter that you're given, the expression that you're given in terms of x. So it's with respect to x. If I am given an expression m squared plus 3m plus 1 like this, it's an expression in terms of m. So this will be dm. That is the integral with respect to m, with respect to m. This one with respect to x. So if we are to take here, we are saying is the opposite. So whatever that you are having, it is going to bring us back to this part that we had before, which is 3x to the exponent of 4. So this is what you're going to obtain at the end. We're going to obtain 3x to the exponent of 4. Then we add the constant of integration. So how to obtain this part of 3x to the exponent of 4 is the one that we need to explain in this class, so that we see how do we oppose this integral. All right, so if we check here, we have got the integrals that we are given, the integral of ax to the exponent of n like this. If we are given this is ax to the exponent of n. So if you integrate now an algebraic term, we are going to obtain ax to the exponent of n plus 1. We add the exponent 1 on the exponent, and we divide by the new exponent, which is n. This exponent n plus 1 is the same n plus 1 that we are having here. So that is the idea that we're talking about. So let us apply this and have it on this question, where we said the integral of 12x to the exponent of 3 is going to give us the same answer, 3x to the exponent of 4 plus c. So let us apply this from this concept that we are given here. So we are given that we remember we have the integral of 12x to the exponent of 3 in this case with respect to x. So that is what we had from this part. Remember, I'm taking from this one. So we want to see if we are going to obtain 3x to the exponent of 4 plus c. So we are given here that if you integrate with respect to x, this term, an algebraic term, we are going to add 1 on the exponent. Is the opposite. Now you add 1. So this is going to give us 12x to the exponent. We add 1 here. This is n plus 1. So this is going to be a 4. We divide by the new exponent, n plus 1, n plus 1. This is the new exponent that you have before. So this is our new exponent, which is 4. So you divide by 4. Then we are going to add the constant of integration. So this one you add for each and every integration that you make. There is a constant of integration to say there might be a constant that was being affected before. That one, remember, the derivative of a constant gives us a 0. So we do not know that was there another term or not. That is why we add this constant to add up our integrals. So if we divide here, that's 12 divided by 4, which is going to give us a 3. So that will be 3x to the exponent of 4 plus the constant of integration, which can be a 0, which can be a 1, which can be a 2. We do not know. So the major part is this part here. Are we having the 3x to the exponent of 4, which was our previous derivative that we had 3x to the exponent of 4. So as you can see, integration, it's a reverse of the derivative. So we are reversing from the derivative. We got a certain answer. If we integrate that answer, it gives us the one that we had given on the derivative. So if integration is a reverse of the derivatives, we are going to see that. All right, this is the first part is fine. So I want us to explain from this part, because most of these integrals you are not given. You are not given, you are just given a few of these ones. So if we are saying the integral, it's a reverse of derivative. Remember, this is under derivative, y, then dy dx. So it means that we were differentiating sine of x before, and we got cos of x. This is under derivative. So it means if we reverse now, the reverse, we are starting from the derivative now. This is the reverse. So if we integrate this part here, the cos of x with respect to x, it means our answer is going to be sine x plus the constant of integration. This is what is going to happen now. The same thing if you consider here, there's a negative sign here. So if you integrate it with a negative sign as it is, that's where it is going to give us a positive cos x. But now take note here, if we are to remove this negative on this so that we remain with a positive sign, just like a positive cos, we want to talk of positive values. So the moment we remove this negative here, it means we are now having a negative. This is no longer a negative. We put a negative this side. You don't just remove a negative, say, I want to remove this negative, so you cancel like this. No, you introduce it on the other side. So it means that we no longer have a negative here. We are left with sine x. So that means that if we are to integrate the sine of x, it is going to give us the negative cos of x. That is what you're going to have. So we are simply saying the integral of sine x is negative cos x. So some of these ones you are given here, if you check, we are given, that is what I'm trying to say. The integral of sine x is negative cos x plus c. Cos x, you are also given for tan, you're also given for sec. But if you check, we are not given the integral of sec squared. You are not given the integral of cosec squared. So on those integrals, you reverse from the derivatives. These ones are for derivatives. So you reverse from the right-hand side to the left-hand side. So what does it mean? It means also, if we integrate this, if we integrate sec x squared with respect to x, our answer is going to be tan x plus the constant of integration plus the constant of integration. The same thing here, it's a negative. So you remove this negative, you put it on this side so that this becomes a positive. So we are going to remain with a negative this side. So this is going to be positive cosec squared x with respect to x. So the integral of cosec squared x with respect to x is going to give us negative cot x plus the constant of integration. This is how you simply do. You simply reverse. The same thing, this one is already positive, so there's no need for us to introduce anything. So we're simply saying the integral of sec x tan x with respect to x is going to give us sec x plus the constant of integration. All right, the same thing here, there is a negative, so we want to make this a positive. We introduce a negative this side. So meaning to say, we are going to remain with the cosec x cot x like this. So what it simply means, we are saying the integral of cosec x cot x with respect to x is going to give us negative cosec x plus the constant of integration. So this is how you reverse your integrals. All right, which is the same thing I want to explain on this part here of a over x. The integral of a over x is a ln x, which was taken from the derivative of ln. If you check here, ln gives us k over x. So if we integrate this, we are going to have k ln x plus the constant of integration, which is this one that we are given. So for ln, we are given for k to the exponent of x, we are also given, or for k a to the exponent of x, like this. If you are given a constant with a to the exponent of x, you're going to use this integral. So, or this is what you simply need to know. These are your standard integrals, all right? But take note on this one. They might give us not direct as it is. They might give us as the integral of ka to the exponent of bx to the exponent of bx. Let's say we are now having, in this case, a letter, in this case, a number that is maybe a 5, a 7, whatever number that you can think of. There's a number here, not direct as what this is x, is 1x. It's difficult for us to actually analyze this integral as it is because there is a 1 there. But take an example, like there's a number which is not 1, like a 2, like a 3. How are you going to integrate this with respect to x? So our answer is going to be ka to the exponent of bx in this case. So this part is going to remain as it is, just like this part is going to remain as it is. But in the denominator here, we are going to divide. So we're going to have over. Take note, we divide by this derivative with respect to x. Remember, this is bx. The derivative of bx gives us a b. So this is going to be b ln of the base, ln a, which is ln this base. It's not changing. So it's ln of the base a. So this is going to be ln of a plus the constant of integration. So take note, guys, when there is a number here, you divide by that number. Remember, on our derivatives, we were multiplying by b here. But I said integration is the reverse. So that's why we have to divide. So that's what you simply do. So this applies even for trig functions. For trig functions, I'm simply referring to these ones that I listed here, or these ones that you are given here. Some of them, like I said, we are given, some you are not given. Like for this part, if they now ask us to integrate the integral, not of sine x, but the integral of sine bx, let us have this as bx with respect to x. What are we going to have? Yes, it's true that the integral of sine, it's a negative cos. But once there is a number here, which is maybe sine 5x, sine 7x, you divide by this number. So it's going to be minus cos of this b. So it is going to be minus cos bx. You divide by this b. Just multiplication, what we had on derivatives, we're multiplying. Integration, it's a reverse. So you divide this time by b. So we're going to have dividing by b, then we add the constant of integration. So this is going to affect on each and every part where there is a cos. If there is an a here, meaning to say we are going to have an a here, you divide by a. If there is a here, we are going to have ln sec a, then everything or that you're going to have, you divide by a. So that is what is going to happen. You are just opposite of derivatives. If you were multiplying, this time you divide by this number. So like I said, it's going to affect every integral that has got a trig function. So I'm not going to explain all of them. You just need to know from this one. So meaning to say here is the same thing, whether it's sec squared bx, this one is going to be tan bx over b. You divide by b. So that is what's going to happen throughout and so on and so on. All right. So that is what you're going to have, guys, on our integrals. So like I said, it's the introduction part that you need to know from your formula sheet, understand your formula sheet, how to apply your formula sheet or how to use your formula sheet. And also, let me see if I added this one. All right, this one I added it here. I talked about this. If it is ka to the exponent of bx, how do you integrate this one from the one that you're given from your formula sheet, which is ka to the exponent of x? All right, so this is the first part of our integration. Then the second part that you need to understand on your integration that you're going to have is the applications of our integrals, where we are given limits. Like we might be given a condition where we have got limits. Like for an example, we have got the integral of a certain function of x with respect to x. Then we have got the limits a and b. Whenever there are limits like this, what you simply do is that you integrate this function. So you're going to integrate as it is usually, you integrate, then you place back your limits. Always it's supposed to be the upper limit, which is the one on top. This is our upper limit, this one. So this is our upper, this is our lower limit. So it is going to be upper limit minus the lower limit. You substitute this value on the integral that you have made, minus you substitute this value on the integral that you have made. So it is going to give you an exact value, not an expression. So this is the one that we are going to use on the applications of area. On under integration, our applications are going to be on area. And our area, according to our syllabus, we only focus on the area that is between. The area is supposed to be between the graph, which is the curve, and the x-axis. So this is what we have in our syllabus. I'm not saying that is what we have in derivatives. I mean, in integration, you say we are only told that the applications of integration is area between the graph and the x-axis. No, it's not like that. It's for our syllabus only. If you move on to N6, you are going to have about even between the y-axis. We are going to talk about a lot there. All right, no problem. So let us see what actually are we talking about on the area. How do you apply your area? Based on the sketch that you're going to have on your calculations, like for an example, I'm having a graph with respect to x, or a curve or a function with y with respect to x in this case. If you consider area, I want to put it this way, where we've got two regions like this one. Let's say it's a cubic function, this one. On our cubic function, we can note that here we have got an x-intercept. Let's say this is our A. Here we've got x-intercept again. Let's say this is our B. X-intercept, let's say this is our C. So, like I said, the area that we are calculating is between the graph and the x-axis. This is where we are calculating our area, between these two. So if we are considering this area, it means according to this whole function, our total area, we have got two portions, two regions that we are talking about, regions or portions that we are talking about. So we are saying there is a region that is from A to B, this one, from A to B, this one. There is a region here from A to B. So meaning to say there's an area that we are supposed to calculate. So let's just say this is our area 1. Then we've got a region taken from B to C, this one, from B to C. That's another region, this one. Meaning to say here, there is another area that we are going to get. So let's say this is our area 2. All right. Every area that you calculate and is above the x-axis like this, it's above the x-axis. So everything that is above the x-axis, anything that you're going to calculate above the x-axis is going to give us a positive area. Then anything that you're going to calculate, as long now it is below the x-axis, below, that is under. So this one, it's on top. This one, it's under. All right. So as long it is below the x-axis, then it means our area in that case is going to be a negative. We are going to obtain a negative value of area. Here you obtain a positive, here you obtain a negative. So the negative part is not our issue. Area, as long you write it, your answer as a positive. Whether you get your area as -5, what you're going to do at the end is to write it as a positive. Like for an example, we got our area as -5 square units. You can leave it like that, or therefore our area there is 5 square units. You write it as a positive. So this is how you calculate area. How, when you are calculating, just know this idea that whatever I'm calculating, what are you expecting to have? So meaning to say, if it is a condition like this, you are going to add these areas together. Remember, this one is a negative, yes, but you write it as a positive. So on the final answer, or on the final presentation, write as positive, Yes, they might give us our area in our memo as a negative. It's fine for them, it's like that, but write your answers as a positive. Therefore, your area is like this as a positive. So if this is written as a positive. If this area that you calculated is a positive, you've changed it to a positive. This one, it's already a positive because it's above the x-axis. So what you're going to do now to find the total area, because there are two portions or two regions here, our total area is going to be area 1 plus area 2. We are going to add this area and this area. In a condition that you left it with a negative, therefore use this formula. The total area is going to be area 1 minus the area 2, which was a negative, in case that you left it as a negative. But in case that you changed your answer and wrote it as a positive, add the two areas. That is how we are going to obtain your final answer. All right, so all along I've been talking about area, this and that. Someone is asking, how do we calculate this area that we are talking about? All right, this is how you calculate your area. So like I said here, we've got two regions. I'm going to talk about this one. We've got two regions. Let me explain on a normal diagram or on a normal curve like this one. So we saw the application of our area, that it can be positive, it can be negative, but your answer, please just write as a positive. No worry for that. All right. So let's say we've got a curve like this, the quadratic function. This is just a normal function that you're given. And we've got limits here, A and B. These are the limits. And we've got a representative strip, which is showing us where our area is being calculated with respect to. So with respect to the x-axis, it's a representative strip to show you are integrating with respect to the x-axis. All right, so this is the whole region. Remember, our area is between the graph and the x-axis, in between. So we're talking about this region here. This is the region where we are calculating our area, but there is a representative strip there. So our area is given by the formula. Area with respect to x is going to be the integral. Remember, this is y is equal to the function of x. So it is going to be the integral of y with respect to x. This is the one with respect to x, with our limits, lower limit, which is a, our upper limit, which is b. So it's taken from a to b. So as you can take note here, this is just an application of limits. Integrate, then put back your limits, you're done. So what you need to understand now is to sketch the graphs. You need to know how to sketch your graphs. All right, sketching of graphs from your mathematics N3. Yes, in our syllabus, we've got the sketching of graph, but most part is taken from your mathematics N3. That is to sketch a normal quadratic function. Know that a quadratic function can be in this manner or it can be in this manner. But like I said, if it is in this manner, we are talking about this area. So your answer is going to be a negative, but don't worry about that negative. So you know your function, how to draw the function, an exponential function, a cubic function, quadratic function, a sine wave, a cosine, the trig functions, all of them, just know how to sketch them. All right, so let us get into applications. Just before, let us finish this one. Let us conclude here. So meaning to say here, if we conclude, because we have got two areas here, so let us just conclude here. Our area 1 is going to be taken from A to B, like I said. All right, so I just want to conclude this one. Remember, I said you are going to add your areas here. You are going to add area 1 and area 2. So we are going to have it this way. Our area 1, which is the integral, this is our area 1, it's taken from A to B. So it is going to be the integral of y with respect to x taken from A to B. That's how you calculate your area 1. You find your answer. Then you move on, you calculate your area 2. Your area 2 is taken from B to C. So this is the integral of y with respect to x taken from B to C. So our lower limit is B, upper limit is C. So like I said, if you calculate this one, because it's in the negative region, it's below the x-axis, you are going to get a negative answer. Then write it as a positive, add to this one, you've got the total area. All right, so this is what you're going to have. The whole of our integration lies on what I have explained right now. The whole of your integration is on this one. And also, don't forget, if you are doing integration, this does not mean that you are not supposed to know these trig. You are supposed to go back to your trig, know your identities, your Pythagorean identities, and also the double angle is unfortunately that we do not have our double angle. This one, we are going to use it again from the cosine. Let's start with the sine. The sine of 2x, which is equal to 2 sine x cos of x. The cosine of 2x, which is equivalent to cos squared x minus sine squared x, which is the same also as 2 cos squared x minus 1, which is the same as 1 minus 2 sine squared x. The way that I'm writing these, you must also be able to write them like this without looking anyway, just direct as it, because these ones, they might ask anything that is about this part. So you need to know these ones by heart since you are not given. All right, so let us rush through the questions and see what we got and how do we apply this concept. We have got the first part of our question, which was to integrate these with respect to x. That is 7 marks. All right, so let me just increase. You've seen the marks. Okay, so this is what we need to integrate. Whenever, so this was from April, that was April 2015. All right, let's see. Whenever, guys, you are given to integrate such type, this is the first part of your integral, where you'll be given each and every term, integrate this and part. So you need to go back to the basics. And our basics are the ones that are introduced here, where we are working from our derivative table. This one, you reverse your derivative table and use also the ones that you're given there. That is these ones that you are given, ax to the exponent of n, and this one. So this is what you do. All right, let us check the first part. We are given to integrate this, and this is 7 marks. If you check here, guys, be honest with yourself in your simplification. This part here, we can't integrate it as it is, direct as it is right now. So it means we are supposed to work it from our trig. That we are supposed to go back to our trig and find a way to make this part for us to integrate this part. All right, so how are we going to do it? All right, this is how you ask yourself. I have sine, I have got cos on the denominator. This is a single term, this is a single term. So these ones can be divided, can be separated. We can separate this as 2 sine of x like this. Cos squared is the same as cos x, is same as cos x times cos x. This one we agree. Same cos times cos, which is going to be cos squared. So if we take it back to our trig part, because we're under trig this one, we're talking about trig. Take note, I'm not integrating right now. I'm just simplifying so that I have something that is in the standard integral. So if we take a closer look here, we are going to have sine over cos on this one. We have got sine over cos, which we know this is going to give us a tan. So meaning to say we're going to be left with 2, and this sine over cos changes to a tan x. Then we are remaining with the cos in the denominator, this one, which simply means that there is a 1 over cos that is remaining here. So you're separating. So 1 over cos of x, we know that from our trig, this one gives us the sec of x. So this one, you check, do you have an integral of such tan and sec from your formula sheet? Can we integrate this part? We can see that we have got the integral from sec tan. Let us check here. If we check here, there is sec tan, which gives us sec x. So meaning to say this one can be integrated. So we are going to write it as sec tan. So we are going to rewrite this as 2 sec x tan x. All right. So that is the first part here. That's 5.1. We are going to have the integral of 2 sec x tan x. We haven't started integrating. Take note, we are still rewriting so that we can be able to integrate our expressions. All right, so that's the first part. Let us move on to the second one. What are we having here? 7 over x to the exponent of 4. So let us write this on top, x to the exponent of 4 on top. So remember, from our exponents, this one is going to carry a negative. So that's a negative 4. So you are just rewriting. This one is already in the format that can be integrated. So you're just going to leave as it is, minus 2x to the exponent of minus 2. Okay, we move on to this one. It's 5x over x squared. We can't integrate that direct as it is. So we can reduce this one. X into x, that's 1. X into x squared, that is x. In our integral, we were supposed to rewrite this on top as 5x to the exponent of minus 1. But under our integral, we do not have the integral of such exponent of -1. Why? Because if we add a 1, this is going to give us a 0. We remain with 5x to the exponent of 0 over. Remember, I said whatever that you get, you divide it back by that. So if we, the moment we just divide by 0, this one no longer exists because it's now approximating to infinity. So meaning to say our denominator is not supposed to be a 0. So meaning to say we can't integrate this one as to the exponent of -1. So we are going to leave it as 5 over x. Why leaving it as 5 over x? Because we have got the integral of such. If you check here, there's an integral that we have got a over x. As long as it's a over x, it can be integrated. So meaning to say it's in the format that can be integrated. So we're going to leave this as 5 over x. All right, so this we multiply, it's a positive, so that's plus 5 over x. So all right, this one is already in a standard form, so we're just going to rewrite as it is, -6/2 to the exponent of 3x. Then this one already is in the standard form. We are just going to rewrite as it is again, which is all right, let us just rewrite this as it is, which is cosec squared x. All right, so this whole part is being integrated. Take note, with respect to x, this whole part is being all right, sorry for that, is being integrated with respect to x. So this is with respect to x. So if this is being integrated with respect to x, we are going to now integrate each and every part. So let us integrate and see what you are going to have. This 2 is a multiplication of the answer that you're going to obtain from sec tan. So if you check, we have got this integral of sec tan. I explained here. The integral is a reverse. Under your derivative, this is where you go, under derivative, because you are not given this integral. So you reverse it from this derivative. Remember, this is dy dx. So I said it's a reverse. So we are going to reverse now. So if we reverse from sec tan, what are we getting here? It's sec x. So we're going to obtain sec x there. But take note, there was a constant here, which is what? Which is 2. So we're going to multiply by 2. So this is going to be 2 sec x. So this is what we are going to have at the end. All right, so I've changed the marker here. So this is going to be 2 sec x. So we are going to remain with the 2 sec x in this case. All right, so that is what you're going to have. And we have got -7x to the exponent of -4. So this one, you use the standard integral. The standard integral is the one of ax to the exponent of n. Ax to the exponent of n. With respect to x, we say this one gives us x to the exponent of n plus 1 over n plus 1 plus the constant of integration. So it simply means that you add 1 on the exponent this time. Instead of subtracting like derivative, you add 1. So this one, if we add a 1 here, this is going to give us a -3. So we're going to obtain something like -7x to the exponent of -3 like this. We have added a 1. Then we divide by the new exponent, n plus 1. Our new exponent is -3. So the moment we divide by -3, this one and this one cancels. It's now a positive. So our answer was supposed to be 7x to the exponent of -3 over 3, which is fine. Or you can rewrite this as take down this down, the x to the exponent of -3, it becomes a positive. So this will be plus 7 over 3x to the exponent of a +3. We take it down. So it is going to be a +3. Remember the reverse part that we had. If it was 1 over x to the exponent of 4, we wrote it as x to the exponent -4. So you can even reverse this to write it as a positive exponent. So this is what I'm trying to explain here. All right, so this is the same thing that is happening on this part. If you check, we have got x there. So you're just simply going to add 1. So if we add 1, this is going to be -2x to the exponent of -2 plus 1, which is -1. Everything over -1. So this one and this one cancels. You were supposed to write your answer like this, which is fine. Or you can simply take the negative down. So it's going to be 2 over x. So this is going to be plus 2 over x. Now we are integrating. That's why we are no longer having the integral sign. We are now integrating. All right, what about 5 over x? We saw that the integral of k over x gives us k ln x. This is what we saw here. 5 over x is same as a over this one. A over x, it's a ln x. So meaning to say this one, it changes to ln of x multiplied to this number on top, which is a. So that is what you're going to do. So meaning to say this is going to be multiplied. All right, I need this page here. This one is going to be multiplied by 5. So it's going to be plus 5 ln x. So over x, 1 over x, it's ln x, but there's a number here which is 5, so it's 5 ln x. All right. Then the integral of this part, remember I explained this one. This one I want to rewrite so that we can properly see it. I don't want to move to the other page. I want us to properly see. I said the integral of ax to the exponent, not ax, but a times k, like this. K times a to the exponent of bx, like this. It is going to give us k a to the exponent of bx over b ln a. So it's going to be b ln of the base a plus the constant of integration. So we are not adding the constant of integration here because we are integrating. We are going to add it at the end. We do not add plus each and every term. No. We add at the end. So if we check here, this is the one that we have here. So this is the one that we are given here, ka to the exponent of x. So we are going to obtain minus 6 times 2 to the exponent of, as it is, 2 to the exponent of 3x over, now this is over b ln a. So our b here is 3. This is our b. So it is going to be 3 ln of a. Our a is the base, which is a base of 2. So it is going to be 3 ln 2. We're supposed to leave our answer like this, which is fine. You can just leave your answer like this, or you can simply divide 3 into negative 6. This is going to give us negative 2. So at the end, we are going to have our answer as negative 2 times 2 to the exponent of 3x, everything over the ln of 2. We have divided this, or you can simply write as it was, minus 6, this and that as it is here, which is fine. So this is how you integrate, guys, each and every term, each and every term. All right, then we move on to this part. There's a negative, it's cosec squared. All right, so here we're talking about cosec squared. What is the integral of cosec squared? Let us check. Like I said, if you do not know this, go back to the derivatives, because there's under derivatives. Here we said cosec squared gives us minus cot. So this is minus cot x. So we're going to obtain a negative cot x there, but multiplied to a negative. So here our answer was supposed to be minus cot x, but take note, there is a minus 2 that we are having here. So we are going to multiply this by minus 2. So minus times minus is going to be a plus. So it is going to be plus 2 cot x. So it's plus 2 cot x plus the constant of integration. After you have integrated each and every term, you write the constant of integration. So this is how you play around with integration. You need to know each and every term, a trig, an exponential, a direct, linear, or whatever. It's an algebraic term. You need to know each and every part. And also to add on our derivatives previously, we were saying the derivative of a constant, it's a 0. But on the integration, it's not like that. The integral of a constant with respect to x is going to give us kx plus the constant of integration. So meaning to say, the integral of 2 with respect to x is going to give us constant times x, which is 2x plus c. So if I'm just given something like this, the integral, they just write the integral dx like this. You wonder to say, which number is here? There is a 1 here. So our answer is supposed to be 1x plus c, of which 1x plus c is same as what? X plus c. So the integral of a constant is that constant times x. Then you add the constant of integration. All right, so this is what we have, guys. That was our first part, having 7 marks to integrate each and every part there, which is 7 marks in this case. Let us move on to the other part, which is integrate like this one, 5.2. Integrate this, evaluate this, like I was saying, that is 3 marks. So these are some of the typical questions. So here we are just given limits in this case. That is the integral of, so we've got 5.2, the integral of dx. We've got limits 8 and minus 6 like that. It's done like this. How are you supposed to integrate this part? All right, so this is what I was trying to say from the previous part, that the integral of a constant, it's constant times x. So here there is 1. So we are supposed to obtain this one as 1x. But 1x, guys, is same as x. So this is going to give us x plus the constant of integration. Then you've got your, this time there are limits. Remember, I talked about the limits from our introduction to say, whenever there are limits like this, you substitute the limits, upper limit minus the lower limit. I just hope I still have that here. This is where we talked about the limits here. Whenever you've got limit, you integrate whatever that you're given, then you substitute the limit, but it's supposed to be upper limit minus the lower limit, where A and B is the upper limit, A is our lower limit. So this is what you're going to do. We have integrated. So, and when we have got limits like this, there is no need for us to write a plus C. Yes, you can write it, but there's no need. I want you to see why there's no need for us to write this. We are going to substitute upper limit minus lower limit. This is our upper limit. So in place of x, you substitute 8 in place of x. Where there is what? X. That is where we are focusing with. So here, upper limit x, which is 8 plus C. C is not x, so you are not substituting anything here. Minus the lower limit. Our lower limit is minus 6. So in place of x, you substitute minus 6. So this is supposed to be minus 6 plus the constant like this. All right, so you can simplify. If you simplify here, we are going to have 8 plus C minus and minus. This is going to give us a plus 6 minus times plus C, which is going to be minus C. So as you can see, C and C cancels. You remain with 8 plus 6, which is 14. So we are going to obtain 14 in this case. So like I said, whenever you are given limits like this, never worry about the constant. You can integrate direct without having your constant this part, meaning to say you're just going to write x. So from this part, you can integrate direct, you obtain your x without the constant, because at the end, the constant will cancel at the end. So you can simply remove it that way. So you just substitute your limits. Your limits, it's 8 and what? 8 and minus 6. Where 8 is our upper limit. So meaning to say in place of x, you are going to substitute 8. So it's upper limit minus the lower limit. In place of x, you substitute minus 6. So this is going to be 8 minus 6, which is going to give us a 14. So as you can see, that is how you apply a question that has got limits. We are going to talk about other limits where there's a trig function, which is different from this one. So let's just hope with time, we are going to reach to that particular type of a question. All right, that was our question 5.2, which was to integrate this part, and we've got yeah, something like 3 marks there. All right. Then if we move on, we've got this typical question, which is on area. Remember, I talked about the applications of integration, that integration can be used now on the calculation of area, like this one. We're asked to sketch this graph and so forth. And so you see 7 marks for everything, to sketch the graph and to calculate the area. So these are the applications now of integration that we also have on the area. All right, so the sketching part, I'm not going to waste much time. Like I said, we talked about the sketching of graphs. All you need is to know how to sketch your graphs. So we're asked to sketch and indicate the area enclosed by the graph. This is our graph. And take note, and the x-axis, it's limited between the graph and the x-axis. Also indicate the representative strip used to calculate the enclosed area. The representative strip is this one that I was indicating with those lines, the vertical lines like this. That's a representative strip, all right? So we just indicate something like this with respect to x. All right, I shall show you. All right, so let us have our curve like we are given. It's between the area is supposed to be between the graph and the x-axis, and we are given the equation that is 5.3. This is 5.3, all right? 5.3, not 5.2, but 5.3. So this is 5.3, 5.31. All right, so we are given the graph of y is equal to 2x squared plus x minus 3. So this is the graph that you're going to take. Y is equivalent to 2x squared plus x minus 3. So whatever that you're given here, in order for you to sketch this a quadratic function, so in order for you to sketch this graph, yes, you can use your table of values where you've got values of x, values of y, then you can draw your graph. Or since here, we know that the major part is the 2 there, it's a positive, so it indicates our shape is supposed to be like this, a positive. If it is a negative, it's going to be an angry face like this one. So we are going to have it that way. All right, so positive is a smiley shape like this. Then we need the x-intercepts for a quadratic function. We need the x-intercepts and the y-intercepts. So we have got the x x-intercepts. The x-intercepts are at a condition where y is equal to 0. So you know that if y is equal to 0, you're going to have 2x squared plus x minus 3 being equal to 0. That's what you're going to have. So what you need here is to solve for x. How to solve for x is you guys, you're going to use your quadratic formula, going to use factorization method. It's up to you. So here I just opted for factorization where I can multiply the first term and the last term I get negative 6x squared, and I need factors of negative 6x squared that I add to get a positive 1 in this case. Factors of negative 6x squared, of which we're talking about positive 3. It must be here a positive 3x and a negative 2x so that it can give us a positive 1 if we add. So 3 plus minus 2, that's a positive 1. So these are the factors. Since here I'm starting with a 2, I can also write it corresponding to this 2x. So I'm going to have it as 2x squared minus 2x. So it's minus 2x plus 3x is a plus this one. So it's going to be plus 3x minus 3 is equal to 0. Okay. So here I can factorize. Remember, guys, your factorization N3 stuff. Factor out what is common here, which is 2x. Then divide 2x squared and 2x, which is x minus 2. That will be minus 1 because the 2 and 2 cancels here, 2 and x cancels, so it's minus 1. Here, what is common is a plus 3. So you can factor out the plus 3. We remain with x minus 1 being equal to 0. So we have got two brackets that you're going to obtain because here we've got a common bracket. So we can factor out our common bracket of x minus 1. We remain with 2x here. Here we remain with a plus 3 equal to 0. So each bracket equates to 0. That means x will be equal to 1 or x will be equal to, we transpose the 3 here. It is going to be minus 3. Then we divide by 2. So that will be minus 3 over 2. So these are the values of x at the intercepts, all right? We have got the values of x at the intercepts. Then we also need the y-intercept. So the y-intercept, it's at a condition where x is equal to 0. So when x is equal to 0, you can simply see that if we substitute here, x being a 0 here, we're going to remain with minus 3. So we are going to remain with y being equal to minus 3. So this is what we have, and this information we can sketch our graph. Remember, the shape, we know the shape that is going to be like this. Our shape is going to be this way. And we've got x-intercept, the y-intercept. So these are the major points that are supposed to be shown on your graph. With these points, it's just a sketch. This one, make sure that you draw properly. Even though it's a sketch, make sure that it's drawn properly. So our x-intercepts, we've got it minus 3 over 2. Minus 3 over 2 is same as minus 1,5. So this is same as minus 1,5. So our x-intercepts are at minus 1,5 and at x, which is equal to 1 here, somewhere there. The y-intercept at minus 3, let's say according to our sketch, this is -1, -2, -3. So that is where we are going to have our y-intercept here. And the shape, it's a smiley one because here it's a positive 2. So it's going to be a smiley shape like this. So just refer back to your N3 sketching of graphs. This can also help a lot. All right. I want this part. I want this part and don't want to remove it. I want it. All right. So that's something like this. All right. So having my sketch here, I'm going to have it this as y is equal to, write the equation as it was 2x squared plus x minus 3 plus x minus 3. This was our graph. So this was our equation, I mean. So this is the sketch that they want. But remember, we are told this is supposed to give us the area between the graph, this one, which is the curve, and the x-axis. We are talking about this region between the graph and the x-axis like this, from -1,5, which is -3 over 2, up to a positive 1. So you can show the representative strip wherever, like this one. This, we can just show your representative strip like this. So this is your representative strip, this one, to show that it's with respect to x, the one that indicates the area. All right, so this is our sketch. Like I said, sketching part, guys, let us refer also to our N3 stuff. All right, this can also help us a lot. All right, 5.32. Now, after sketching this graph, they are now asking us to calculate the area using integration. This is the most important part. Our application states that to calculate area, it must be from integration. But they're saying the enclosed, the one that is being closed by the graph and the x-axis, that is enclosed, this one. the one covered by this graph and the x-axis. Which area are we referring to? There is an area that is closed there. This is the one that we indicated here. So this is the area that we are supposed to calculate, this one, the enclosed part, this one. So how are we going to calculate our area? That is where we go back to our formula and say that our area with respect to x, so this is 5.32, our area with respect to x is taken from the integral of y with respect to x taken from a to b. So this formula you are given, which is an advantage in our formula sheet, we've got this formula. So y is simply the equation. Y is equal to, this is our y here. So this is the one that we are substituting. So our y there is going to be, so we are going to have our area with respect to x, which is the integral y, which is this part with respect to x. That is why we take the part with x. So with respect to x, we've got 2x squared plus x minus 3. So this is what you're going to integrate with respect to x, taken from the limits of -1, which is -3/2. So this is our lower limit. This is our upper. So upper, that's the bigger value. 1, it's bigger than -1, a negative value compared to a positive value. A positive one is the bigger value. No matter how it sounds, -1, a positive value is the bigger one. So 1 is our upper value. So we've got 1 here. Our lower, which is at -1, So this is what you're going to find, or what you're going to do to find your area. You integrate this, you substitute your limits. And also I said from the beginning of the class, if you are calculating an area below the region, below the x-axis like this, expect your answer to be a negative. That one, you must have that expectation. You are calculating, know that your answer, it is going to be a negative there. If it was above the x-axis, therefore our answer was going to be a positive. If it was like this, our answer was going to be positive. But this one, it gives us a negative area, which you can write as a positive, which is fine. All right, so let us perform our integrals, guys. So here we are. We need to integrate this part. Remember, we talked about the integral. Integration is the reverse of derivatives. And when we are integrating, we add a 1. So we're going to add a 1 here, which is 3. So this is going to give us 2x to the exponent of 2 plus 1, which is 3. We divide by that exponent, which is 3. Then we move on to x, we add 1. So this is already 1 here. X to the x is just x to the exponent of 1. So the moment we add this one, this will be a 2. So we are going to remain with x squared over the new exponent, which is 2. So it's over 2. Then we've got minus 3x. Minus 3 is a constant. Remember, I said the integral of a constant, it's constant times x. The integral of k with respect to x is equal to kx plus c. So this is the part that you're going to apply. You can write the plus c here, but whenever there are limits like this, I said it's not necessary for you to have the limits. So for you to have the constant. All right, so just have your limits up limited to 1 from -1, 5 up to 1. So we remember our concept always, we have to substitute the upper limit minus the lower limit. So it's always that part upper minus lower. So meaning to say our area with respect to x, we are going to substitute our upper limit in this case, which is a 1. So it means wherever there is x, wherever I'm seeing x, I'm going to substitute the upper limit. So we are going to have something of this nature. In place of x, we substitute our upper limit, which is 1. So it's 2 times 1 cubed over 3 plus, in place of x, that's 1 squared over 2 minus, in place of x, we substitute 1. So this is what you're going to have. So this is our upper limit. So as you can see, we substituted everything in place of x with the upper limit minus the lower limit. So our lower limit is the one that is affected by -1, 5. So in place of x, I'm substituting -1, 5. So it's 2 times -1, 5 cubed over 3 plus, in place of x, -1, 5 squared over 2 minus 3 times -1, 5 like this. So this is what you're going to do. So if we simplify this, we can choose to simplify it 1, that is this part, you find your answer. Whatever that you get, you subtract to this one, which is fine. You can do it that way. So here I obtained something like -11/6 On this one, negative 27 over 8. So if I combine everything here, if you combine everything, that means we are going to obtain something like as a decimal 5,208,3333 and so on. So to 3 decimal place, that's minus 5,208 square units. So if you check here, your area, it's a negative. Where I was saying it's because of the region, the side where it is located, it's below the x-axis. The area is below the x-axis. That's why it's a negative. But on your final answer, don't worry about this. Just present it as a positive, or you can leave your answer as it is, as a negative, which is fine. But our area, guys, it's a positive value. Don't you think so? So that will be the best way. So therefore, our area with respect to x is going to be 5.208 square units. We do not have square centimeters, square meters. We write as square units. The reason is we are not given the units there to say these are centimeters. We are just given values. So that's why we write as square units, or you can write it as a square units like this, which is one and the same thing. All right, so that is how you calculate your area. It's all about integrating, then substituting of values. That is the upper minus the lower limit. All right, so let us check what we had from the other parts, but these are the steps that you're supposed to take in order for you to attempt this typical question from 5.31, the sketching of the graph, then the calculation of the area. All right, another part of our question here was to calculate using the integration. All right, simplify with, okay, simplify 3 marks, this one, simplify on 5.4. All right, so let me increase this one. We're asked to simplify this integral. They can ask just a simple question like this, but it's not that simple. It's not that simple the way that it seems. All right, so let me increase a little bit. All right, so this is what we have. This was having 3 marks. How do we integrate this part? That is the question. We've got a square root in this case, which is something else that we're talking about here. So it's very, very difficult for us to integrate this. But if we think along the lines of trigonometry there, if we think along the lines of trig, we can see that here this part can be actually simplified, because we know that 1 plus tan squared x is equivalent to sec squared x. We are also given this on our formula sheet. That's why I said you must know your trig. On this part I explained, let's just hope I still have that information here. We explained here that where are they on top here, these ones. We see our some of the integral, some of the trig part that you're given. You're not given everything, but you're just given this part. You're given at least the first part. So we know that here 1 plus tan squared gives us sec squared. So we're going to take it as sec squared there. So that is the one that you're going to take. So meaning to say here, I'm going to replace sec squared x in place of tan squared. So meaning to say at the end, all right, sorry for this. So at the end, like I was saying, we're going to write it as sec squared. So this is going to give us the integral of the square root of this whole part is sec squared. So we are going to obtain sec squared x with respect to x. We have got the square root of a squared, just like the square root of 2 squared, which, you know, this is 2 from square root and square cancels. Remember, how do you remove a square? Introduce a square root. So where there's a square root and a square, this one simply neutralizes to sec x. So we are going to have the integral of sec x. Here we are not integrating. This is just from our trig part, where we know that this square root is same as to the exponent of a half. So half of 2 gives us a 1. So this will remain with sec x with respect to x. Then we need to integrate sec x. We are also given the integral of sec x here. I want you to check this part. We are also given this integral of sec x that is down here. We have got the integral, which is ln sec x plus the constant of integral ln sec x plus tan x. Let's check here. We have got it. We have got, okay, maybe I'm under the other part, but here, there we are here. So if we check here, we have got the integral on this part here of sec x, which is ln sec x plus tan x. So this is the one that we are going to use, which is ln sec x. So our answer for this one is going to be ln sec. All right, so we are going to obtain our answer as a ln sec x plus tan x in this case, plus the constant of integration. Remember, we have got the constant of integration. Whenever there are no limits, that part is supposed to be there. All right, so as you can see, that was 20 marks on this question. It was actually 20 marks on everything to integrate, finding of area using the integrals on this whole part. This is how they ask these questions, and this is actually 20 marks, as we can see here. So let us have another question so that we can properly see how do they play around these questions. Let us know more about these questions. All right, so if we check here, we've got another question that you're going to consider. That is to integrate. We've got 20 marks again. So these are the typical questions, like I say, that you need to know in preparation of what exams. So we are given integrate. This is 7 marks from this part. So let me just try to increase everything so that you can properly see. So this is what we have. So just like the previous part, we need to rewrite whatever that you're given here in a format that can be integrated. So we are going to have, that is 1.1. So we have got the integral of, take note guys, this is a fraction, 2 over sine, 2 of, this is, everything is like in the denominator. The trig part that we have is in the denominator, which is difficult for us to work with. So let us write in a format that is applicable. Let's take these ones on top. So how can we take these ones on top? That is the question that you need to ask yourself. So the 2 is already on top, so it's not affecting us. So this is going to be 2. This is same as 1 over the sine of x, like this. 1 over, because it's in the denominator, so it's 1 over sine x. Remember, 1 over sine gives us cosec. So that will be cosec x. The same thing with tan. 1 over tan of x is the reverse from cot. So 1 over tan gives us cot x in this case. So why writing this format? It is a format that we can integrate. We have cosec x, cot x. This one can be integrated. So that's the first thing that you need. All right, so the same thing here, we've got -7, which is on top. So the -7 is not affected, but sine is in the denominator here. So you've got 1 over sine squared. Remember, we said 1 over sine gives us cosec. So if it is 1 over sine squared, it is going to be cosec squared x. So this will be 7 minus 7 cosec squared x. All right, this part is in the normal form. So there's nothing that you're going to do here. So it's plus 4 pi to the exponent of 3x. All right, this one also is in the same format that we are used to. Maybe you can just write as -4 over 3 e to the x, that you just separate, but it's the same thing. We can just write as -4 over 3 times e to the exponent of -4x. So, all right, then we've got the same thing, just like this part, 1 over cos on this part. So we've got 1 over cos of x. So this is plus 1 over cos gives us a sec. So this is sec x. Then we have got 1 over cot x. So cot, just like here, 1 over tan gave us cot. 1 over cot is a tan. So this will be a tan x. All right, then this part is just a constant. There's nothing that you're going to do there. Just write as it is, 7 pi over 8 like this. So this is the whole integral that we are supposed to have, this whole part here with respect to x. So from this part that we had before, this part that we had, we managed to rewrite this whole expression in this format. Once you have got this format, it means we can integrate with everything. You were rewriting in a format that you can integrate. So if you find anything now that cannot be integrated here, it means you haven't expressed that in a normal format, because you were rewriting in a way that you can be able to integrate. All right, so let us perform our integration here. So this is going to be 2 cosec cot. Remember, we said we can reverse from derivatives because we are not given this in our formula sheet. So we reverse it from derivatives. If you do not know the answer direct, therefore reverse it from your derivatives here. So this is what we have here. Cosec, the integral of cosec x, cot x with respect to x gives us minus cosec x. So our answer there is going to be a minus cosec x. But because there is a number here which is 2, so it's going to be minus 2. So take note, you multiply by the number that is there. So it's minus 2 cosec x. All right, so this is how you simply integrate, you reverse from your derivative. All right, the same thing here. We have got a -7, which is going to multiply the integral of cosec squared. So let us get back to our formula. Our formula sheet, cosec squared here, the integral of cosec squared with respect to x, we said our answer is supposed to be minus cot x. So we are going to multiply whatever that we have there by minus cot x. So this is -7 times minus cot x, which is our integral. So take note there, it's a minus there, which is actually important for us. So -7 and minus, that's a plus. So we're going to have +7 cot x. So this will be +7 cot x. All right. Then we've got the integral of this part. This one, I actually like to write it down, because if I take it from the other page, it might confuse us. Let me write it again. Remember, I say the integral of k a to the exponent of bx with respect to x is going to give us k a to the exponent of bx like this over b ln of a plus the cost of integration. So this is the b that we're going to divide with here. So meaning to say, we are going to have our answer as this part is going to remain as it is, as you can see from the numerator here on top. So this is going to be plus 4 times pi to the exponent of 3x, but it's over the derivative of this. This is the b is from derivative. It's actually supposed to be like this. If we talk it, if you take it to your N5 level, you are going to be having it like this. K a to the exponent of f of x with respect to x is simply k a to the exponent of f of x over the first derivative. So it's the first derivative with respect to x of ln a plus c. So this is the first derivative of this gives us a b, but for our level, guys, we do not have much. So just take it as a 3 down. Just take this 3 down, which is going to be 3 ln of pi, the base, ln of a here. This is our base. All right. So this is the same thing that you're going to apply on E. E, it's same application as pi. E, it's a number. As long as it's a number, there it's a 2, it's a 7. E, it's also a number. So E, it's not like X. It's a number, remember, 2,7 something. So we are going to use that same application here. So we are supposed to obtain this part. Okay, let me write it here. This one, let me try to write it here before we simplify it. We're supposed to obtain this part as it is, our constant, this part as it is. All right. So this was supposed to be minus 4 over 3 times e to the exponent of minus 4x in this case. Everything over the derivative of this, which is the b on down here. So it's going to be minus 4. So we're going to have it as a minus 4 in the denominator times the ln of the base, which is ln e in this case. All right. So as you can see, you've got negative, which gives us a positive. Just divide these numbers. 4 over 3 divide by 4. This is going to give us something like 1 over 3. We're supposed to obtain something like this. 1 over 3 times e to the exponent of minus 4x over ln e like this. But remember that ln e is equal to 1. So you can even simplify it, because you know that ln e is equal to 1. So you can leave your answer as this, or you can write it as 1 over 3 times this part with exponent of minus 4. Like I said, ln e is equal to 1. But you can even write your answer like this, which is fine. Or you can write it as plus. Remember, it changed. This one minus gave us a plus. So it's plus 1 over 3 times e to the exponent of minus 4x. So like I said, you can write it this way with a and e. All right. Then we move on to the integral of sec x. All right, so in this case, we need to integrate sec x tan x. So this is sec x tan x, sorry, there's sec x tan x there. So we go back to this part. The integral of sec x tan x with respect to x gives us sec x. So our answer there is going to be a sec x. So we are going to have our answer as plus sec x. Then we have got this part here, the integral of 7 pi over 8. This part, we do not have x. It's a direct constant, that one. We do not have x. So since I said the integral of a constant with respect to x gives us kx plus c. So meaning to say this is our k, which is a constant. So our answer is going to remain with the 7 pi. So we're going to have 7 pi over 8 times x now, which is kx. Then we add the constant of integration. Since we are done integrating, therefore we are going to write our constant of integration. So this is the whole part of your integration. What you need to integrate this type of an expression, rewrite whatever that you're given in a manner that can be integrated. Once you have this in the manner that can be integrated, therefore integrate everything. Don't forget the constant of integration. So as you can see, this question was actually let's check here. It was 7 marks. So meaning to say each part is given a mark. This is 1, 2, 3, 4, 5, 6, 7. Each part is given 1, 1, 1, 1, 1. So this simplification, they expect you to know it direct. Just play around with your trig, play around with your exponents and so forth, so that you can integrate direct. All right, let us move on to this part. Simplify the integral, or simplify and integrate the following. And that was main marks, 5 marks for that. All right, so let's see what we're given here. I'm just going to rewrite this side so that we can integrate it properly. So we are given to integrate with respect to x. So this is 1.2. All right, so that's 1.2 here. So we need to integrate with respect to x, which is 7 cos of x times the sine of x plus 9 everything over cos squared. So this is cos squared x according to what we are given. This is cos squared. This is just cos x. So if you check from this one, it was if you're actually using this direct question paper, you see that it was a wrong presentation on the memo where they use this as cos squared. Yeah, this is cos x, not cos squared. This is the one that has got cos squared. All right. So this is a trig that you are supposed to work with for us to integrate. You need to ask yourself from your trig, what can I actually do? There are two terms on the numerator here, and I've got a single term in the denominator. So what I can simply do is to separate them. Remember, we said a plus b over c gives us a over c plus b over c. That's a over c, b over c. So if we are given this, you can separate this over cos squared and also 9 over cos squared. So meaning to say, before you integrate, that's the first thing that you're supposed to do, to write in a way that can be simplified. So this is going to give us, let us rewrite. So we are going to have a 7 cos of x, sine of x, everything over cos squared x. So this is cos squared x plus 9 over cos squared x also. So this is what you're supposed to have. So if you check here, we're supposed to simplify further. Here there's only one cos. So this cos and these two of them, which are here, cancels, will remain with cos x here. So you're supposed to remain with cos x, which we can simplify because we are now having sine x over cos x like this. And we know that sine over cos, it's a tan. So this is going to give us 7 tan of x in this case, sine over cos, that's a tan. If it is cos x over the sine of x, this one gives us cot x. So take note about this part on our trig simplification. Then we've got 9 over cos squared x. Remember, over cos, now 1 over cos, it's a sec. So this one is going to give us 9 sec squared. Since there's a squared here, it's going to be sec squared x. All right. So meaning to say, this is what we are going to obtain from the simplification of this whole part. After expanding it, we are going to obtain this part here. So this is what we are going to integrate now. So meaning to say, we're going to have the integral of 7 tan x. So this is 7 tan x plus this one is going to be 9 sec squared x with respect to x. So we are going to integrate this with respect to x. All right, 7 tan x, we have got this integral in our formula sheet, the integral for tan, which is ln sec. If you check here, down here, if you check, we've got the integral of tan, this part here. So tan gives us the integral of tan x, it's ln sec x. So this one is going to give us ln sec x. All right, so take note about this integral. All right, so this is going to be ln sec x. But taking note that there is a 7 there, which is multiplying. So this 7 is just a constant. It multiplies our answer. All right. Then sec squared, we also have this from the reverse of our derivatives. If we go back to reverse our derivatives, we are going to have this as from this part here, sec squared. We talked about it again from our reverse here. Sec squared, on this sec squared, if we reverse it, it was taken from tan. So meaning to say, if we integrate sec squared, it gives us tan x. So this is going to be plus tan x. So we're going to have plus tan x, but there's a 9 that is multiplying. So it is going to be plus 9 tan of x plus the constant of integration, since we are not given the limits. So this is how you were supposed to simplify this type of equation. You simplify first in a manner that can be integrated, then you integrate at the end. All right, let's check the other part of our question. So this was 1.2, which was having 5 marks. If you check here, that was 5 marks. All right, then the applications of area on question 1.3, we've got 1.31, which is to sketch this part and calculate the area and so forth. All right, so let me just try to increase. So these are the two questions that you are given. The first part, indicate clearly, sketch and clearly and indicate the area enclosed by the graph of this. All right, so this is an exponential function. I talked about the exponential functions. This part, you need to know how to sketch your graphs. All right, let me just write them aside so that we can know how to sketch these graphs. For an exponential function opposes a log function, whereby we are saying if we are given y is equal to a, let us put as k so that we not confuse a, k times a to the exponent of bx like this. It can be to the exponent of bx, whatever term that you're going to have on this part, as long it's a single term, not an expression. Like we are not adding one in this case, it's just a single term that you're given. The sketch that you're going to have, if this b is a positive, if this b is a positive, if b is greater than 0, that means if b is a positive value, our sketch is going to be like this. This is how we are going to have your exponential function. So this is an exponential function. It will be tending as if it want to approach to 0 in the x values. So it will be like it's approaching 0, but it passes through the y-axis at a point where x is equal to 0. We know that this is going to be a 1, then 1 times k, it is going to be k. So it is going to pass through the y-axis where x is equal to 0 at a point referred to as k. Then it continues like that. So that is what you're going to have. So this is the function of y is equal to k times a to the exponent of bx, which is an exponential function. Like I said, it passes through the y-axis at a point which is referred to as k, this point here. So meaning to say, if this is a positive, this is what you're going to have. What if it was a negative? What if b is less than 0 and it's a negative value? Like, so the examples for the first one, this one that I put have indicated here, it can be y is equal to 2e to the exponent of x, y is equal to 3 times 4 to the exponent of 5x. As long as it's like this, you simply have the same shape. All you need to know is that it is going to pass through the y-axis at these points. That is for this one at 2, for this one at 3. So they've got same shape. All you need is to know how to have a sketch of this type of a graph. Each graph, you need to know how to sketch it, all right? Then we also have, like I said, it can be a negative like this. If it is a negative, it means our graph was going to be like this. This is for a negative. So we've got our x and y axis here at 0 here. So it's just going to be like a reflection where we are having these values now taken this way. So we're going to have it this way. So it will be like it tends to approach 0 here, but it won't reach the x-axis. So that is now when we are given as y is equal to k, a to the exponent of minus bx like this. So passing through the same point, which is passing through at k in the y-axis, because if this is 0, we are going to simply have a to the exponent of 0, it's 1. 1 times k, that's a k. So it's going to pass through this point at point k, just like this part. So all you need is the shape. So this is what you are given here. They are asking us here to sketch this graph. The first thing, sketch clearly and indicate the area enclosed by this graph of y is equal to 2e to the exponent of x. As you can see, it's an exponential function. There is e. E goes where there are numbers as long it's a number to the exponent of x, e it's also part of those graphs. So it's part of this type of a graph. So simply you're going to have this sketch here, the first one, because it's a positive one here. If you check here, this is 2e to the exponent of x, which is a positive one. So if it is a positive one here, it means we're going to take this one where b is a positive. Remember I said if b is a positive, we are going to take this one. So this is the shape that you're. All right, so having our graph here, like I said, it's just the same as the one that we are having for the a to the exponent, which is a positive. So meaning to say this one is going to be taken as, okay, so let me just reduce. This one is too big now. All right, so let me just reduce. So you're gonna have it this way. It's a positive, this one. So that means we are going to have the shape in this manner where it is a positive. So like I said, it will be tending as if it want to approach the 0 here, but it won't. So this is at a point where x is equal to 0 here, it is going to give us a 2. So this is going to pass through the point 2. So that's a sketch, this one, right? So we are supposed to have it accurately. You can just have your points. So this is our 0, just like 1, 2, 3, 4, 5, and so on, -1, -2, -3, -4, and so on. All right. With our sketch, we are not only to draw. We are given a condition that it must be indicated and it must be between the x-axis and the coordinates. Now we are limited the coordinates or the ordinates taken from x is equal to -1 and x is equal to 1, meaning to say we are limited from -1 up to +1 with a representative strip. All right, so this is what you're going to have this way. So we are going to limit this graph to -1 up to +1. This is where we have -1 here. This is where we have our +1 here, taken from -1 up to +1. So meaning to say, we can indicate to say this is where we are going to calculate our area in between from -1 up to +1. So we can just have our representative strip. So remember, this representative strip is just to indicate that our area is calculated with the x-axis, so it's with respect to x, which is delta x. All right, so this is how we could have sketched the graph of an exponential function. So you need to know each and every graph, how to sketch it. So that was the first part of our question. Then the second part of our question, which is on 1.32, was now to calculate using integration the magnitude of the area indicated now in the question or in question 1.31. This part that we had before on question 1.31, this is the graph that we drew from that part. From this graph, they're saying we must now calculate the magnitude of the area. So how are we going to calculate our area? Remember, I said area is simply the integral that you're going to have with respect to x. So this is 1.31. So our area with respect to x is going to be the integral of y with respect to x from a to b, which you are given this formula. So this is taken our a, which is our lower limit, which is -1. So that's from -1, our b, which is our upper limit, which is a +1. So we are going to integrate y, which is this function. This is the one that you're supposed to integrate. That's your y there. So meaning to say, this is going to be the integral of from -1 to +1. So that's -1 to +1, y being 2e to the exponent of x. So this is 2e to the exponent of x with respect to x. So we are going to integrate this. We get our limits into consideration. Therefore, we've got the exact area. So remember, we talked about the integral of such type of functions where we ended up having 2 times e to the exponent of x over, this is a 1 here, so it's going to be 1 ln of the base. So this is just ln e in this case. And we know that ln e is equal to 1, like I said. So if ln e is equal to 1, it simply means we are just remaining with the 2e to the exponent of x plus c. But since there are limits, there is no need for us to put back the limits. So just need the c there. We've got limits, so there's no need to put the c there. Here, there's no need for us to write. We can write that, there's no problem, or just leave it like that. All right, so we are going to substitute the upper limit minus lower limit, which is 1 in place of x. So this is 2e to the exponent of 1 minus the lower limit where x is -1. So in place of x, we are going to substitute -1. So this is 2e to the exponent of x here, which is -1. This we can simplify direct on our calculator. So if we simplify this on our calculator, this is going to give us the exact area of 4.700,804.7 like that. So you can round off to 3 decimal places. That will be 4.7. That's 1, 2, 3. So this will change this into a 1. So that's 0.1 square units in this case. So this is how we can use our integrals to calculate the area. Integration, the application, major application that we have is on the calculation of area. So that is how we could have calculated this part. And that was the last part of our question, having 20 marks, that is from 1.32. All right, so I want us to check the other part of the question here, which is that is question 5. We are asked also to simplify the first part of our question. That is having, in this case, 3 marks. So this is November 2015, which is very, very important now. They do ask these questions a lot if you check. All right, 5.1, simplify this with respect to t. So how can we simplify this with respect to t? This one we can simply rewrite, taking this on top. This is same as the integral. If you check here, this is same as the integral of 1 over t to the exponent of 7 with respect to t. So we are now dt, it means we are integrating with respect to t, that's why. So if we interchange this right on top so that we can integrate properly, that will be equivalent to t to the exponent of -1. So it will be t to the exponent of -7 with respect to t in this case. So this is what you're going to integrate with respect to t. So remember, the integral of such type of expressions, you simply add 1, then you divide by the new exponent. So if we add 1, this is going to give us t to the exponent of -7 plus 1, that's -6, and you divide by the new exponent, remember our concept, then plus the constant of integration. So this we can rewrite negative on top. So that will be negative t to the exponent of -6, everything over 6 plus the constant of integration, which you can leave it like that, or you can write it back as a positive exponent as it was before, meaning to say we take this down. So this is going to be -1 over 6t to the exponent of 6 plus c from our laws of exponents. So you can even write it this way, or just leave it like that. All right, so that was the first part of our question in this case, where we are given to just simplify. Then question 2, determine, that's the integral of this part, 2 cos x, that's 5.2, and this is having something like 3 marks. All right, so we are given in this case, let us just save it aside. So this is the integral, that's 5.2. The integral, we have given limits here, pi over 4, 0, this is 2 cos 2x with respect to x in this case. All right, so how can we integrate this part? If you check here, it's a trig function, and there is a 2 in this case. Remember what I said, if there is a number on a normal integral, if you integrate cosine of x with respect to x, remember the cosine of x was taken from sine. So if you differentiate sine, you get cos. So if you integrate cos, you simply get a sine again. So it was supposed to be sine x plus c. But the moment you've got a number here now, where it is now given as cos bx with respect to x, as long as there's a b here, it is going to give us sine bx over b. You divide by that b again here. So this is what you're going to have. So this is the condition that we are given here. We have got a 2 here, which is affecting cos. So meaning to say our integral here was supposed to give us, I want us to simplify this aside, we're supposed to obtain, remember, cos changes to a sine. So this is a constant here, meaning to say if there is a constant here, you simply multiply also by your constant. All right, so here there's a constant 2. So you're going to have 2 times, we integrate now, which gives us sine bx. So this is going to be sine 2x. So you're going to have sine 2x over the 2 here. So it's going to be over 2, which is our b. So this part and this part can cancel, this 2 and this 2 can cancel, meaning to say the whole part is going to give us sine 2x. All right, so meaning to say here we are going to obtain sine 2x after integrating with our constant of integration here plus c. But like I said, if you are given a condition like where you've got limits like this, the plus c is not necessary, so you can leave it aside. Just write your limits pi over 4 and a 0 there. So this is a trig function. Take note, whenever you're given a trig function with these limits, it means you are supposed to be in radians in this case. You're supposed to use your calculator in radians. So what you're going to need in this case is to change your calculator function to the radian concept. So let me have it this way so that we can see this part with a calculator here. Let us try to have it this way so that we can see our calculator. All right, so this is what we have here. If you check this one, there's a D here. It means my calculator is in the degree mode. So I have to change this pi over 4 to degrees. But if I will use radians, I have to change here from my setup here. I'm supposed to change this to a radian. All right. So this, I need the mod part here. So if you check the state, then there is a ratio. All right. All right. Alpha. Okay. This one, I'm used to the other one. All right. So here I'm going to go down. Is it the same part that I'm repeating? Seems like I'm repeating the same thing here. I'm repeating the same thing. It's supposed to give me this option if I say alpha like this. All right, alpha, meaning say this button was not pressing properly. So there, you check 3, it's for degrees, 4 is for radians. So as we want the radians on 4, so we're going to press 4. Our calculator now is showing this error here in radians. So it's shift this one. So it must show this S. When you press the shift, there must be S like this. Mine was not, you see this one, shift here. So you mod, then radians, it's 4, degrees, 8, 3. All right, so that is the concept that you're going to have in this case. So as we can see now, our calculator as it is now, it is in radians now. Our calculator as it is, it's in radians. So meaning to say we can substitute this one in radians. All right, so let us write first, then we can substitute upper limit minus lower limit. So it's going to be sine 2 times pi over 4 like this. Then in place of x, we substitute our lower limit, which is 0. So it's minus sine 2 times 0 like this. My calculator being in radians, I'm going to change this. So I'm going to have sine 2 times pi over 4. So this is pi here over a 4. So this is over 4 like this. All right. So if we simplify this, we are going to obtain a 1. So from this part, we obtain a 1 minus sine 2 times 0. 2 times 0 is 0. So we are going to have sine 0 like this. We are going to obtain a 0 from there. So meaning to say from this whole part that we are having, our answer is going to give us 1 in this case. All right, so we're going to obtain a 1. So that's one, just 1 here. So this is just 1. This is not area, so I'm still having area in my mind. So this is just 1, okay? 1 minus 1, which is 1 minus 0, which is just going to give you a 1. So this is how you play around this simplification. All you need is to understand each and every part that you're given. All right, so that was our question 5.2. 5.3, which is back to that part that we talked about previously, where you need to integrate each and every part where you are given 7 marks in this case. All right, so let us check what we got here. Integrate, let's try to increase like this one. All right, so the first part here, if you are to check, we are given, it's a square root of this part and so forth. So like I said, all you need is to write in a format that can be integrated in this case. So if we check this first part, guys, we've got a lot of complicated things that we are given there. We've got a lot of things that are complicated. Okay, so let me explain it under here. So this part, let us just try to simplify it. We are given it as the square root of x into 1 plus x squared like this over x. So this is over x. Okay, if we check properly, this is over x. So we talked about the issue of separation of a fraction, where we can separate a fraction in this case, but which is in this case, we can just, as a single, this part is just can be divided together, this part. We can divide this, meaning to say we can apply our laws of exponents here. We have know that Square root of x is same as to the exponent of a half. So this is going to be x to the exponent of a half into 1 plus x squared. Everything over x, which you could have now divided by x. But now you take note, we still have this part, which is a lot. So what you can simply do is to divide this first part here, because this is a single term outside of the bracket. Also, this one is a single term. So you can divide these ones separately, from which concept x to the exponent of a, when divided to x to the exponent of b, it gives us x to the exponent of a minus b. So meaning to say, here we are going to subtract a half minus, here there's an exponent which is 1. So if we subtract x to the exponent of a half minus 1, that is going to give us x to the exponent of minus half. So we are obtaining x to the exponent of minus 1 over 2 into this bracket. This one, we have already divided this part. So it's no longer there. This is the one that we are having here. So meaning to say, we are focusing with the left part, which is the bracket, which is 1 plus x squared. So what it means, this part is supposed to expand the bracket, each and every term multiplied by x to the exponent of minus half. So if you multiply the first part, what are you going to have? It's x to the exponent of minus half times 1, which is x to the exponent of minus half. It's just times 1 times any number, guys, which is just gonna be a 1. All right, why? Okay, let me check, guys. Let me check. I'm seeing something here. This is 1 plus x squared. Sorry for that. This is 1 plus x squared outside of the bracket. So meaning to say, here we are supposed to have it this way. This is 1 plus x squared. From this part here, let me just correct here. 1 plus x squared. The squared is outside, squared. So meaning to say, we can't simplify it like for now. What we need is to expand this bracket, okay? 1 plus x squared. Let us expand our bracket. So if we expand this, it's like we've got two brackets, or you can use that identity that I explained before. Remember, a plus b squared is equal to a squared plus 2ab plus b squared. So meaning to say, you can use 1 squared in this case, which is going to give us a 1 plus 2 times 1 times x, which is going to be 2x plus x squared. Or you can open two brackets, expand them. Then after that, now you can expand by x to the exponent of minus half, which is this one. It's going to be x to the exponent of minus half. You multiply this one and this one. So you're multiplying. So this time you add the exponents. So this is going to be plus 2x to the exponent of minus half plus a 1. This is a positive half. Then we do the same thing. We are multiplying the bases, which are the same here. So you add the exponents minus half plus a 2. So this will be 3 over 2. It's going to be a positive. So that's plus x to the exponent of 3 over 2. Take note, guys, this whole part that we have here, it was just a simplification of this part here, just to simplify so that we can be able to integrate this. We're just rewriting in a manner that we can be able to integrate this. So this is what we obtained from the first part, this one. So we are going to start with this integral that we are given, this last part that we got here. So meaning to say, here we are going to have this whole part was going to give us, that was 5.3. So that's 5.3. We are going to have the integral of this part, that's x to the exponent of minus half. Let me try to reduce this way. All right, so we want to take as it is here. So this is x to the exponent of minus half plus 2x to the exponent of a half plus x to the exponent of 3 over 2. These ones can be integrated. We have written in a way that we can integrate. So meaning to say, that is the first thing that you need each and every part. So this whole part, it was just rewriting so that we can be able to integrate. Otherwise, without rewriting this way, it was going to be very, very, very difficult for us to integrate. So we are done on this part. We move on to the other part. We have got minus 3 ln x. There's nothing that we need to change there. We are just going to write as it is. So this is minus 3 ln x. All right, this one also, there's nothing to change there. 3x to the exponent of 10. Then we move on to the trig, 3 over cos squared. So this is same as 3 plus 3. So you're given plus 3. Then we've got 1 over cos squared. Remember, 1 over cos, it's a sec. So this one is going to be sec squared x. So this is the whole part that we were fighting for so that we can be able to integrate. All right, once you have written in this format, guys, it's up to you now. You can integrate each and every part. So let us start with the first part. So this is going to give us, remember, for every part with x, since it's with respect to x, we are simply going to add 1. We divide by the new exponent. So if we add 1 here, that will be a half. So it's x to the exponent of a half divided by a half like this, which is same as you're going to divide. You have integrated, but simplify also, because you can't leave your answer like this. So this is 1 divided to 1 over 2. So if you divide this on your calculator, this will be 2. 1 divided by a half is 2. So that will be 2x to the exponent of a half, which you can write it in this manner, which is fine. Or you can write it as a square root, 2 square root of x, just like the previous part they gave us in terms of root signs. So you can write it this way. So that is the first part that you're going to have. All right, we move on to the next part. Like the first one, we add a 1 here. So if we add 1, this is going to be 3 over 2. So we are going to have 2 times x to the exponent of 3 over 2. Remember, you divide by the new exponent, which is you divide by 3 over 2. So this is same as 2 divided to 3 over 2. So if you divide 2 and 3 over 2, you are going to obtain something like 4. So this is going to be 4 over 3. So we are going to obtain 4 over 3 here. Then x to the exponent of 3 over 2, which you could have written this way, but know that to the exponent of 3 over 2 simply means the square root of, this is square root to the exponent of 3. So this is going to be the same as the square root of x to the exponent of 3. That's another way of writing, or you can just leave it like this. All right, that is the same thing that you're going to do here on x to the exponent of 3 over 2. All right, I need the eraser, not this one. All right, so this is what you're going to do on this part of x to the exponent of 3 over 2, this one. So we are going to add 1. So like I said, we add 1. So if we add 1 on 3 over 2, that will be to the exponent of 5 over 2. Everything over 5 over 2, the new exponent. So here you divide 1 divided to 5 over 2. This is going to give us 2 over 5 x to the exponent of 5 over 2, which you can leave it like that, or you can write it as 2 over 5. Remember, the denominator in the square root. So that's the square root of x to the exponent of 5 from our exponents. All right. So this is what we could have done on this part. Then we move on to the integral of ln. We are given it as ln of x. Is it ln of x? But this one we do not have in our syllabus. All right, ln 2. Okay, I was actually surprised what happened, because the ln of x is integrated by the one that is called by parts, which we do not have in our syllabus for N4. So I was actually surprised. Yes, so this is a mistake. It's supposed to be ln 2, the way that is written there. This is ln 2. So if we take it this way, 3 ln 2, this is a constant, guys. It's like 3, it's like 4, it's just a normal constant. So meaning to say, if you integrate this, you are going to obtain minus 3 ln 2 times x. Remember, every integral of a constant is multiplied by x. Remember, I said the integral of k dx like this, k with respect to x is going to give us kx plus c. So this is what we are having. So meaning to say, this is going to give us ln x plus c, which is 3 ln 2 times x. All right. We move on to 3x to the exponent of 10. So this is the same thing like the previous part, where we add a 1, we divide by the new exponent. So if we add a 1, this is going to be minus 3x to the exponent of 10 plus 1, which is 11. We divide by the new exponent, which is 11. So this is, we are done. We can't simplify further. Then the integral of cos x squared. So cos x squared is a reverse from our derivatives. Remember, when you differentiate tan, you get sec squared. So if you integrate sec squared, that will be a tan, or you simply go back to that part that I had before. So this will be 3 tan x plus the constant of integration. So this is how we could have integrated this part. As you can see, it's just the same way as the previous part. So that is how they try to play around us, guys, with these integrals. So all you need, guys, is to know the basics, all the basics of your integrals, and also to work with other topics like trigonometry, to understand much of it, and also your exponents. All right. Then on the other part, you're given to sketch and clearly indicate the area enclosed by the graph of, take note, the same graph that we had before, an exponential. Y is equal to k times a to the exponent of bx. This is the same graph that we are having. If b is a positive, we know that this graph is going to be tending to be approaching to the x-axis. That is what we are going to be having. It will be tending as if it's approaching to the x-axis like this. So it passing through the point k. Like I said, this is k, where we are having y-axis, x-axis, and this is 0. So if you are to consider here, we are going to see that, okay, there is a k, which is our k, which is our 3 in this case. 4 to the expo is a positive, just like this part. When it is a positive, so meaning to say we are having the same shape or the same graph. All right. So that was our question 5.41. All right. So 5.41, we are going to have it this way. 5.41. We had this one before. So this is an exponential function. So this is what you're going to have here, x and y like this. So like I said, same shape, so it's going to be having the same shape like this. All right, so that's y is equal to 3 times 4 to the exponent of x, passing through the y-axis at 0.3, where x is equal to 0. So that's at 0.3 in this case. All right, so we are asked to take this between the graph and the x-axis. So this is our graph, this is our x-axis. From 0 to 2, remember, you'll be having your points. This is -1, and so forth. You'll be having maybe -1, -2, -3, +1, +2, +3. So we are now asked that this area is supposed to be taken from x is equal to 0 and x is equal to 2. We are limited. This is our x, which is equal to 0. That is this point. To x is equal to 2. X is equal to 2 at this point. So this is, we are limited to this point where x is equal to 2. So our area is bounded by the graph and the x-axis is limited in between. So meaning to say, we are having a cross-section here, the area in between, bounded by this graph in between like this. So this is what you're having in actual sense. So the representative strip now is the one that is showing the x-axis. So you can just indicate our representative strip in between our area like this. So this is our representative strip, which shows us we are integrating with respect to x. So this is the first 3 marks that you're given to sketch this graph clearly. So this is what is supposed to be indicated clearly. All these, the limits, you know where to start. You're starting from 0, you are ending to 2. From the information that you're given, the values of x here, that is where you're limited to. All right, so that is our first part. Then 5.42 was to calculate using integration now the value of the enclosed area. We're talking about area enclosed. Enclosed between what? The graph and the x-axis. That is where we are limited or where we are bound. All right. So like I said, area, guys, is direct. Area is simply the integral with respect to x. So that's 5.42, where our area with respect to x is going to be the integral of y with respect to x taken from a to b, which is our limit. So that's a, b in this case. So that means our area with respect to x is going to be y, which is this function here. That is the function for y that we're given, which is 3 times 4 to the exponent of x with respect to x from the limits 0 up to 2. So it's taken from 0 up to 2. So what you're simply going to do is to integrate. So once it's integrating, then you need to know which integral are you using here. In our formula sheet, we are given this integral. The integral of kx to the exponent of n with respect to x is equal to ka to the exponent of x over the ln of a plus c. This one we have, like I was explaining before, if there is a number here, then you have to consider that number also here. But here we do not have this number, so you're going to use as it is. So meaning to say our answer is going to be as it is here. That is ka to the exponent of x as it is, which is 3 times 4 to the exponent of x over the ln of the base, which is the ln of a. So it's going to be the ln of our base, which is 4. So this is going to be over ln 4. Taken our limits from 0 to 2. So that's from 0 to 2. The plus C, it's not a matter of fact. You can use it, but it's not a matter of fact there. So our area, substitute upper limit minus lower limit. So this is 3 times 4 to the exponent. Our upper limit is 2. 4 to the exponent of 2 over the ln of 4 like this. So here we've got our upper limit minus the lower limit taken when x is a 0. So this is 3 times 4 to the exponent of 0 over the ln of 4. So this is what you're going to have at the end. All right, so with your calculators, guys, here there's no need for us to simplify this one aside and this one aside. Yes, you can do that. If you want, you can simplify this aside, you get an answer. You simplify this one aside, you get an answer, or just simplify everything at once. So the area with respect to x is going to be 32, 4606 3842 and so on, which is going to be 32.4612 3 decimal places, which is in square units. So this time there's a need for us to have the square units because this is area. We are talking about area in this case. So as you can see, guys, what is important in the first place is the simplification. Are you having the simplification in a proper manner that can be integrated? If you are having in a proper manner that can be integrated, the next thing that you need there is to integrate whatever that you are given. Substitute the limits whenever you are given the limits, then you need to substitute those limits like what you're given for the integral. So this is the major part of our integration. This is the major part actually of our integration. So all we need is to work with more question papers, That's a revision, which is a very, very strong revision that you're going to have. Work with more question papers, revise them as much as you can. For more questions, let us drop them on the comment section so that we can know. Make sure that you join the membership. Join the membership. By joining the membership of the channel, that enables you to ask your personal questions. Those personal questions you ask them, we have them, then we post back to YouTube so that each and everyone can answer. But it's actually your personal question that you have asked. So this is the importance of joining membership, and also it's helping us to grow. As we can see, it's a way of saving lives. Another one needs this information. So by joining, you are simply giving us another energy to work on more questions, more revisions that can actually help another person, which is very, very important for us. Let us keep on supporting the channel so that we can move on, grow as a family. Make sure that you invite your friends, invite your colleagues so that they also can benefit from whatever that you're having, which is just a free thing to us, or a free, okay, let me just leave the word free, which is something that is important for us to use in our revision. It's a tool for revision that we are using, a very, very important tool. So let us bring as much as we can to the family so that we also benefit as a family and reach more souls outside there. But for now, guys, that's what we have from Mezon African Motives, working on mathematics and for till we meet again.